Hello everyone, my name is Yordan. I'm from Bulgaria, and I'm here to talk about our experience with OpenNebula and how we integrated it in our systems. And this will be more like a story. Hopefully it will inspire any of you who is still on the fence and not yet decided to do this. So here we go. This is about me. So I was working at telecoms about 10 years, and 5 years ago I started a company together with colleagues. The company is called Innologica, and we do enterprise telecom solutions, but our main product today is that we're going to talk about today is Inoreader, and let me get to this in a moment. So first, what we're going to do, I will present, already presented myself, I will present my company, and what was the issues that we faced with our product, and how did we mitigated them. And I will share some maybe useful tips for you, and then we'll have some questions later. So our company is situated in Sofia, Bulgaria, and we have a very sunny office. And as I already mentioned, we started 5 years ago. We mainly we only do software, so we are developers, and currently our main product is Inoreader. Now, Inoreader is, for those of you who aren't familiar with RSS, this is an RSS aggregator. It delivers news from different sources and aggregates them into a single stream, so you can read all your news in one place without having to visit separate sites. But it can do a lot more than this. This is just the base of the product. And what we do is we have identified that many people like to not only to consume this news for themselves, but they like to manage those news and to have tools that can then allow them to organize those news and do some stuff automatically, like notifications and newsletters and etc. So some facts about the product: we already have 1 million users registered, 200,000 monthly active users, and currently in our database we have more than 70 billion articles and more than 10 billion coming every day. So we have to deal with this volume, and then of course we have to distribute them to the users. And we have more than 1 million feed updates per hour. This means our crawlers need to update all those feeds each hour, and there are more than 15 million in the database. And currently our OpenNebula instance has more than 60 virtual machines spread on 14 physical hosts. So not that much, not that big, but still a lot. This is a lot for us. So what kind of issues did we face, and what was our main driver to choose OpenNebula 1 year ago? So mostly we had this. Those are all our own servers, but they are situated in a co-location space, so we have to pay rent for the cage. So if you notice, we were completely filling the rack space, and also the storage on those servers was completely full. Now, all services that we run there, I mean web servers, application servers, and databases, everything was without virtualization on the bare bones server. So one server had one role, that's it. And half of those servers were databases, mostly MySQL and Elasticsearch databases. And they were all using 4 or 8 hard drives in a RAID 10 arrays. And all of those were full. So we couldn't expand easily. We needed to purchase new servers every 2 months to keep up with the volumes that we need to deal with. and those servers were just sitting there idling on their CPUs, just having to keep the data. And the second problem was, of course, hardware failures and the fact that we didn't have full redundancy on each component, only on some databases and some web servers. So if a failure happens, it needed to be dealt quickly, and most of the times it resulted in some kind of an outage, more or less. So what we did, we sat together with the team and we decided it's time to take action. And at first we were just looking for a storage solution, and this is how we actually met the guys from StorPool, because they are practically our neighbors in Sofia. And they told us, hey, why are you still using servers and bare metal servers? Why don't you use virtualization? We are greatly integrated with OpenNebula. You should totally check it out. So we told ourselves, why not? Let's check this out. And it turned out to be, for a guy with almost no experience in virtualization, it was really easy to grasp at the beginning. And then in just a couple of months, I should say we were proficient in OpenNebula enough to run it in production, or even less than 2 months. So here is roughly how it happened. And it was November last year, so exactly 1 year ago, we chose that we will go with OpenNebula and StorPool. We then purchased the hardware, and we had until January 2018 to make tests and make everything work without actually having the hardware needed for StorPool, because we waited long. It was holidays and a lot of companies didn't work there. And in February was our main execution that we will show with pictures there, and then as a story. And in March we were completely ready. So now we are just from time to time upgrading something, and that's it. So for hardware, we chose Supermicro because they were recommended as a vendor. We were using Supermicro for a lot of time. Most of our servers were Supermicro. And for switches, we went with Quanta. And for 10 gigabit hosts, we refurbished our old servers because, of course, you saw that we had a pile of servers just sitting there doing mostly nothing. So we just upgraded their CPUs and memory, and we reused them. So this saved us a lot of time, a lot of money, and we have purchased a lot of other stuff like 10 gigabit cards and everything. All this started to come slowly into our office in the next month. So this is there are some details here that you will be able to see later. If you download the presentation, there will be a link at the end. So about details about the hardware that might help you if you decide to head on to this adventure someday. And from here, I will talk about how we actually did the execution part after we purchased all the hardware and we started waiting for it to arrive. So first thing that we did immediately after deciding that we will go with this setup is we installed OpenNebula on 2 servers, 2 hosts, with a shared NFS storage. So we played a lot with OpenNebula there. Then we tried almost everything that we can think about to break it, and there was a lot of issues at the beginning, mostly because of our still initial understanding of the solution. But quickly we quickly realized that it's very easy to find any mistake that you do, because there are lots of log files, and in OpenNebula you just need to look for the specific issue. And during this time, we also managed to migrate some of our services to virtual machines. They were at first there was only development environments, but in about a month we felt confident enough to migrate actually running production services to those two servers without still having StorPool on site and everything else. So this was our initial experience with OpenNebula. And then we rented a new rack after the hardware arrived, so we were ready. We rented an empty rack, and we decided to start green there in the same data center. So we to install StorPool, and after that, host by host, to move servers from the old rack and upgrade them with CPU and memory and use them as hypervisor hosts until we migrate everything. So not to make a mess in the old rack, but start a completely new one. So the hardware arrived at our office, and then we quickly, the very next day, we moved the hardware to the new rack. Of course, with the help of StorPool, the guys then did all the installation remotely of their node. So in a day, it was installed with 10 gigabit network. The full storage cluster was running. We still didn't have any hosts there, but the very next day, we installed the first two hypervisor hosts, and those were the first two machines that we were playing with for the last 2 months. So there, we had already built our complete cluster, but the virtual machines were still running on the shared NFS storage of those two servers. So the next step was to migrate the virtual machines to StorPool. And of course, this happened with a lot of help with the guys from StorPool, but the process is somehow documented here if you are curious. So the process is to shut down the current running virtual machine, create the StorPool volumes, copy them using DD or other Linux tools. Of course, again with the help of StorPool with shell scripts. Then reattach the volumes via Sunstone and power up the virtual machine. Then you just need to check that everything is working correctly. And there is some cleanup work after that needs to be done. And because we were using mostly persistent virtual machines, it was very easily for us to just use the recovery function of OpenNebula. We used the delete recreate function, the recover, which completely cleans up the deployment files and removes everything from the old data stores. Of course, you shouldn't do that if the virtual machines are not non-persistent, because this then clears the current state of the hard drives. And one by one, we moved hosts by host into the old rack. So we move, for example, 2 or 3 web servers in a virtual machines with less power but enough to run the services, and we completely free the physical servers of those services. For some servers, we had tangled services, like for one server we had MySQL database running, but at the same time it also had bind, for example, for DNS, which was bad. So we needed to remove first those dependencies, and we created separate virtual machines for every small service that we run. And when a server was pulled out of the old rack, we then completely refurbish it, remove all the hard drives from the server because they were just thin hypervisors without local storage. We have upgraded all the CPUs using the same type of CPU that was available. We chose a CPU that was both cost efficient and very, very fast for those motherboards. And all of the servers were upgraded to 128 gigs of RAM. So this make our cluster completely, all the servers were the same kind of CPU and the same memory, so we don't need to deal with that. We don't need to worry about different CPUs. I will talk about this in a moment. How is this helping us to achieve better performance? And also, by removing all the hard drives, we were also removing all the RAID controllers. So it allowed us to install the 10 gigabit cards for the storage. And the whole storage network is with two 10 gigabit switches, 48 ports, and each server is connected with two separate interfaces to each switch for redundancy and for performance. And then we just install those refurbished servers in the new rack. And this cycle is repeated continuously until we migrate everything. So this happened in February this year, and it took us about 2 or 3, maybe 3 weeks to completely move everything. So another thing that is not mentioned in the slides is that some of the servers were not reused. They were retired from this co-location facility, and we built another data center in our office where we used those servers for backup purposes and other stuff, but we don't use all our old servers because they were with older architecture and not suitable for this. So at the end, we were able to improve our rack space dramatically and our storage dramatically also, and of course this allows us to expand greatly because right now we can utilize all of those servers more evenly, and we can have our CPU and memory more evenly distributed between servers and not having to worry about filling the hard drive of a server because they don't have local storage. We only use StorPool for that, so we can distribute it. And everything is 100% virtualized. It consumes less power, so it reduced our power bill, and of course it makes it all a lot more greener solution. And the performance gains are also noticeable, and the service runs a lot faster because we are using faster CPUs with higher clock rates in a single core. So for MySQL this is quite important, and for our web services also. And here's a glimpse of our dashboard. I don't know if the numbers are not clearly visible, but we have 400 CPU cores at the moment and 1.5 terabytes of RAM. So it should be enough. If you see the graphs, we have not allocated even the half of it yet. So it should be enough for the foreseeable future. We only may have to upgrade StorPool at some point because we currently have 30 terabytes and we are using more than 20. So we will have to upgrade that at some point, but it's easy because we have rack space. We just add the next server and tell the guys at StorPool, hey, here's your new server, join it to the cluster, and there we go, we have more space. You can see how our hypervisor hosts are balanced. So we are mostly leaving everything to the default scheduler to worry about that. We don't manually distribute virtual machines. We only try to distribute if we have, for example, 10 web servers, 10 application servers from something. Of course, we don't want all of them running on the same host, because then if the host fails, we'll have again an outage. We don't want that. And there is a high availability currently implemented from the standard documentation of OpenNebula. It works like a charm. The only tricky part was the fencing mechanism, because it is somehow related to the hardware, and Supermicro fortunately have reliable IPMIs, like HP have their ILOs. So fencing was really important during the high availability setup. And some takeaways for you that might be useful. I mentioned that we use the same model of CPU everywhere. All of the hypervisor hosts use the same CPU. So this enabled us to go into the template and set the CPU model to host pass-through. This feature, I think, is available for 5.4.6, so should be pretty common these days. There shouldn't be installations with older versions than that in the wild. So if you have the same kind of CPU in your cluster, it should be pretty safe to enable this option. In other case, if you don't have the same CPU, you should be careful, because if you live migrate a virtual machine to a different kind of CPU, I think it will crash at the moment, because it will not recognize it. For the older virtual machines that were not started with this template option, you can either update, just shut it down, reconfigure the virtual machine, or if that doesn't work for some reason, because we had some instances that refused to take the option, you can use the raw data, just pass this option in the raw data. And this is more StorPool related observation. We have spoke with the guys then, but if you make large volume, let's say 3 or 4 terabytes, and you use the default MKFS without the minus uppercase K, it uses trim, and unfortunately it consumes a single. This is the second, is on the hypervisor host, so it's only on a single thread, so it consumes all the I/O operations on the host for 5 or 6 minutes, so your virtual machines might starve. In this case, you just use the -K option on MKFS, so this was kind of important for us at the beginning. That's why I mentioned it. If you have a similar installation, maybe if you have a storage driver that also reports to the virtual machines that it supports stream, this may happen too. So beware if you format large volumes, 4 terabytes or more. And the next, of course, this tip might be obvious to some, but it wasn't to us at the beginning. If you have separate 1 gigabit network and 10 gigabit networks, you definitely should think about your hosts to talk via the 10 gigabit network, because live migration then happens almost instantaneously. For example, for 8 gigabits of RAM, for a virtual machine with 8 gigs of RAM, it takes about 7 seconds to migrate. And on a gigabit network, of course, it takes a minute, so it's considerably faster. And some other smaller tips that you will mostly be able to check later if you download the presentation. Some tips about how to mount your drives with faster, without cache and native I/O. So you might get some more IOs from your virtual machines this way. And some other stuff that we did, because we were used to build telecom systems, and of course those are more monitoring systems, so we are kind of fans of monitoring solutions. We have our internal monitoring solution that we won't be able to show you here, but we made some Grafana. We actually used some templates available, but we adapted them, and those were then transported to our own dashboard. So we were able to put this TV in our office, and we can see both of our OpenNebula instances, how much virtual machines we have running, how much of them have issues, and some other Grafana templates are in the presentation as well for you to use. And StorPool also gave us access to their Grafana, so we can see how are the volumes used, and basically that's it. So this is it for our story. Thank you very much. And if you have some questions.
Okay. Yeah, we have some time for questions. Does anybody have any questions for